In the vast cosmic ocean of galaxies, there's one that stands out like a celestial oddity, Hoag's Object, a perfect ring of stars floating in space, defying everything we thought we knew about galaxy formation. But here's the real mystery. Hidden within its dazzling structure are 50 bizarre objects that shouldn't exist. From rogue planets with impossible orbits to ancient star clusters that predate the galaxy itself, each one tells a story that challenges our understanding of the universe. And today, we're diving deep into these cosmic anomalies where science meets the unknown, and every discovery feels like uncovering a secret the universe tried to hide. At the heart of Hoag's Object lies a mystery so perplexing it rewrites the rules of galactic anatomy. While most galaxies anchor themselves around supermassive black holes or dense star clusters, this one flips the script entirely. Its core glows with an eerie, uniform light, no violent jets, no swirling accretion disk, just a serene ball of stars that shouldn't exist in such perfect equilibrium. Astronomers expected chaos, but instead they found cosmic harmony. The luminosity is all wrong, too brighter than predicted, as if the core is being powered by some invisible engine science hasn't named yet. Even stranger, the absence of a supermassive black hole, a universal staple in galaxies this size. It's like finding a clock with no gears ticking flawlessly against all logic. This defiance of expectations forces us to question our most fundamental models. How do you build a galaxy without the usual gravitational anchor? Could there be entirely new physics at play here, hidden in plain sight? The more we study this silent rebel of a core, the more it feels like we're decoding a message from a universe far stranger than we ever imagined. But what truly makes Hoag's Object a cosmic showstopper isn't just its mysterious core, it's the breathtaking ring of stars encircling it, so perfectly symmetrical it looks like it was drawn by celestial architects. Most galaxies with rings are messy, warped by collisions or gravitational tugs, but here the outer band is almost unnervingly precise. The stars orbit in near-perfect alignment, creating a glowing halo that defies the chaotic nature of the universe. So how does something this pristine even exist? One leading theory points to an ancient collision, a smaller galaxy plunging through Hoag's Object billions of years ago, its debris sculpted into this flawless ring by gravity's invisible hand. But there's a problem. No trace of that catastrophic event remains. No stray stars, no scars, just this elegant structure floating in isolation. Another idea suggests the ring formed from internal instability, a ripple in the galaxy's own gas and dust that somehow froze into this perfect shape. Yet neither theory fully explains why it hasn't degraded over time. Rings like these should fray or distort, but Hoag's Object holds its form like a cosmic artifact preserved in amber. It's a puzzle that makes astronomers wonder, are we seeing a fleeting moment of balance or evidence of forces we've yet to discover? One thing's certain, this isn't just a ring. It's a celestial whisper, challenging us to rethink how beauty endures in the violent theater of space. Moving inward from that hypnotic ring, astronomers stumbled upon another enigma, a vast, starless void separating the outer band from the core. Most ring galaxies show a gradual transition with scattered stars bridging the gap, but Hoag's Object presents a stark divide instead. It's as if someone drew a cosmic boundary, forbidding stars from settling in this forbidden zone. This absence defies conventional models. Gas and dust should have collapsed into stars here over billions of years, yet the region remains eerily dark. Some researchers propose a violent past. Perhaps the gravitational shockwave from an ancient collision cleared the area, like a celestial broom sweeping away stellar debris. Others speculate that magnetic fields or exotic dark matter structures actively suppress star formation, creating this unnatural vacuum. But the most tantalizing idea. The gap might be a fossilized snapshot of a rare evolutionary phase, a fleeting moment when a galaxy's internal dynamics conspire to keep this region pristine. Whatever the cause, this starless chasm forces us to confront an uncomfortable truth. Our theories about how galaxies age might be missing a critical piece of the puzzle. And until we solve it, Hoag's object will keep its silence, holding the secrets of the void. Scattered like sapphires along the outer ring of Hoag's object, intense blue star clusters gleam with youthful energy, a stark contrast to the serene golden glow of the galaxy's ancient core. These aren't just random sparkles, they're cosmic nurseries where stars are being born at an astonishing rate. Their vibrant hue betrays their age. Blue stars burn hot and fast, living short, brilliant lives before flaming out. Normally, such clusters would be scattered unevenly, but here they're packed together with almost mathematical precision, forming a necklace of stellar newborns around the galaxy's edge. What's baffling is how recent this starburst appears. Most galaxies slow their star formation over time, but Hoag's object seems to have reignited its creative fires. One explanation points to a hidden reservoir of gas funneled into the ring by ancient tidal forces, providing fresh fuel for new stars. Another theory suggests these clusters were sparked by shockwaves rippling through the ring, perhaps echoes of a long-forgotten collision. Yet there's no visible culprit, no neighboring galaxy that could have triggered this sudden burst of activity. Even stranger is the way these blue clusters are arranged. Instead of drifting apart, they cling to specific zones within the ring, as if guided by an unseen blueprint. Some researchers speculate that dark matter's gravitational scaffolding might be herding them into place, while others propose magnetic fields sculpting the star-forming regions. Whatever the cause, their presence rewrites the story of Hoag's object. This isn't just an aging galaxy, it's a cosmic phoenix, still forging new stars against all expectations. And every cluster is a clue, hinting at forces we're only beginning to understand. While Hoag's object dazzles with its visible structure, the real cosmic heavyweight might be something we can't even see. Wrapped around this galaxy like an invisible cloak, a massive dark matter halo could be the hidden architect behind its strange stability. Most galaxies rely on dark matter's gravitational embrace to hold their shape, and the way stars move within Hoag's object suggests it's no exception. The clues lie in the galaxy's rotation. Stars on the outer edges orbit just as fast as those near the core, a phenomenon that defies the laws of gravity unless there's far more mass than meets the eye. Ordinary matter alone can't explain this speed. Something unseen must be anchoring those stars in place. That's where dark matter comes in, its gravitational pull acting like an unseen hand keeping everything in balance. But here's where the mystery deepens. While other galaxies show similar rotation curves, Hoag's object's pristine ring and undisturbed core make it harder to pinpoint exactly how the dark matter is distributed. Some models suggest its halo could be unusually smooth, lacking the clumpy substructures we see elsewhere. Others argue the ring itself might be a tracer for dark matter's influence, its perfect symmetry sculpted by an underlying gravitational framework. Not everyone's convinced, though. A handful of researchers propose alternative explanations, modified gravity laws, or unaccounted for stellar populations, arguing that dark matter isn't the only possible answer. Yet the sheer elegance of Hoag's object structure, paired with those stubborn rotation speeds, keeps bringing scientists back to the dark matter hypothesis. If proven, this invisible halo wouldn't just solve one puzzle, it could rewrite how we understand ring galaxies altogether. After all, the universe's greatest secrets aren't always written in starlight. Sometimes they're hidden in the dark. Nestled within the shimmering ring of Hoag's object, a series of dark, twisted ribbons cuts through the starlight warped dust lanes that refuse to follow the galaxy's otherwise flawless symmetry. Unlike the smooth, evenly distributed dust seen in most galaxies, these filaments twist and knot in unpredictable ways, as if frozen mid-movement by some unseen force. Their chaotic shapes stand out starkly against the orderly backdrop, raising the question what could have dragged these lanes so violently out of alignment. One compelling explanation points to gravitational encounters with unseen cosmic neighbors. Dwarf galaxies, invisible from our vantage point, might have brushed past Hoag's object in the distant past, their fleeting gravitational tugs distorting the dust like fingers stirring smoke. Alternatively, massive interstellar gas clouds collapsing under their own weight could have plowed through these regions, leaving behind ripples in the dust like wakes in a pond. Yet there's no obvious culprit nearby, no visible intruder to blame for the disruption. Another puzzling detail is the dust's uneven temperature. Some patches glow faintly with residual heat, suggesting recent turbulence, while others remain cold and inert as if frozen in time. Could this be evidence of multiple disturbances, stacking over eons like layers in a geologic record? Or does it hint at something stranger, magnetic fields or radiation from the core subtly warping the dust from within? The most intriguing possibility: these twisted lanes might be fossils of a long-lost conflict, remnants of a smaller galaxy torn apart as it spiraled into Hoag's object. The dust's irregular distribution could be the final traces of that ancient merger, preserved like scars in celestial amber. Yet without clear debris or stellar trails to confirm the theory, the truth remains just out of reach. What's certain is that these dust lanes are more than mere cosmic clutter. They're a turbulent counterpoint to Hoag's object's serene beauty, whispering of violence beneath the harmony. And as astronomers map their intricate shapes, they're left with a humbling realization. Even the most perfect-looking galaxies hide chaos in their shadows. Amid the brilliant blue star clusters of Hoag's object's ring, a few crimson anomalies stand out, lonely red giant stars burning like dying embers in a field of sparks. These ancient stars shouldn't be here. The rest of the ring is alive with youthful stellar activity, yet these red giants appear as relics from another time, their bloated forms betraying advanced age in a neighborhood of newborns. How did they end up stranded in this celestial nursery, so far from their peers? One possibility is stellar migration. Violent gravitational encounters may have catapulted these aging stars outward, hurling them from the galaxy's core into the ring like cosmic exiles. If true, their journey would have taken millions of years, a slow-motion ejection frozen in time. But there's a hitch: their distribution isn't random. Instead of being scattered haphazardly, they cluster in specific arcs, almost as if placed there deliberately. Another theory suggests these red giants formed in place under freakish conditions. Dense pockets of gas in the ring could have collapsed early in the galaxy's history, birthing stars ahead of the current wave of blue clusters. Yet that raises another question: why didn't more stars form alongside them? It's like finding a single oak tree in a field of saplings, with no explanation for its solitary maturity. The most tantalizing idea involves captured stars, ancient wanderers stolen from a dwarf galaxy that strayed too close. If confirmed, these red giants would be cosmic refugees, their chemical fingerprints revealing origins far older than Hoag's object itself. But so far, their composition matches the galaxy's own, deepening the mystery. Whatever their origin, these crimson outliers are more than misfits. They're living records of the galaxy's untold history, written in the slow burn of aging starlight. And unlocking their secrets might just reveal how galaxies cheat time itself. Among the many mysteries of Hoag's object, one theory stands out as both elegant and contentious. What if we're not looking at a unique cosmic oddity, but something far more familiar, just seen from a perfect angle? Enter the polar ring galaxy hypothesis. Imagine a typical spiral galaxy, but with an extra ring of stars and gas orbiting at a right angle to the main disk. These rare polar ring galaxies exist, and some astronomers argue Hoag's object might simply be one of them, caught in a flawless face-on view that makes its ring appear perfectly circular. The idea isn't without precedent. galaxies like NGC 4650 showcase these perpendicular rings clearly, their structures warped by ancient collisions that sent debris spinning in a new plane. If Hoag's object fits this category, its symmetry could be a cosmic illusion, a trick of perspective masking a far more chaotic history. But here's where the theory hits turbulence. Most polar ring galaxies show visible distortions, warped disks, off-center cores, or uneven rings. Hoag's object, by contrast, is unnervingly precise, with no obvious signs of the gravitational wrestling that typically shapes these systems. Even more puzzling is the starless gap between the ring and core. Polar rings usually connect to their host galaxies through faint bridges of stars or gas, yet Hoag's object maintains its stark separation like a forbidden zone. Proponents counter that we might be seeing the system at a uniquely stable moment before gravitational interactions distort it further. Skeptics, though, point to the absence of nearby galaxies that could have supplied the ring material, a key requirement for the polar ring model. Then there's the matter of age. Polar rings are thought to be relatively short-lived, their delicate balance eventually crumbling under gravitational strain. Yet Hoag's object's ring appears ancient, its stars too settled for a recent collision. Could it be a polar ring that somehow defied the odds, surviving billions of years intact? Or is it something entirely different, a cosmic one of a kind? The debate rages on, a reminder that sometimes the universe's most beautiful puzzles refuse to fit neatly into our boxes. Deep within Hoag's object's glowing ring, another layer of mystery unfolds, one written not in light but in metal. Unlike most galaxies where heavier elements like iron and oxygen become scarcer as you move outward, this cosmic oddity flips the script entirely. Here, the metallicity gradient, the way these elements are distributed, doesn't follow the rules. Instead of tapering off, certain patches of the ring blaze with unexpected concentrations of heavy metals, as if someone scattered cosmic treasure in deliberate, uneven pockets. This bizarre pattern challenges everything we know about galactic chemistry. Normally, stars nearer a galaxy's core forge heavier elements over generations, while outer regions remain relatively pristine. But Hoag's object's ring defies that logic, with metal-rich zones appearing far from the center, mixed seamlessly with younger, metal-poor stars. It's like finding a bustling modern city in the middle of an ancient forest, utterly out of place yet undeniably real. One explanation points to a dramatic past. If smaller, metal-rich galaxies were absorbed into Hoag's object long ago, their material could have been strewn unevenly across the ring, creating these chemical hotspots. Yet there's no visible debris left behind, no telltale stellar streams or distorted orbits to support the idea. Another possibility: the ring itself might be a crucible for exotic star formation, with turbulence or magnetic fields concentrating metals in certain areas like cosmic eddies gathering flotsam. But the most tantalizing clue lies in the blue star clusters themselves. These young, fiery stars often show unusual chemical signatures, as if they formed from gas already peppered with heavy elements. Could supernova from earlier stellar generations have seeded the ring with metals before these new clusters ignited? It's a cosmic recycling story with missing chapters, one where the very ingredients for starlight seem to have appeared out of sequence. Whatever the cause, this rogue metallicity gradient is more than a curiosity. It's a fingerprint of processes we've yet to fully understand. And as astronomers map these elemental oddities, they're left with a humbling truth. Even the periodic table, humanity's guide to the building blocks of reality, might need rewiring when it comes to Hoag's object. Tucked away in the faint outer reaches of Hoag's object, almost invisible against the black canvas of space, ghostly tendrils of hydrogen gas weave through the darkness like cosmic cobwebs. These delicate filaments, only detectable with the most sensitive radio telescopes, tell a story the galaxy's pristine ring tries hard to conceal, a history etched in gas. While the rest of Hoag's object gleams with order, These wispy structures hint at chaos lurking beneath the surface. One school of thought argues these filaments are cosmic scars, the last remnants of a smaller galaxy torn apart long ago. If true, its gas was stretched into these faint trails by tidal forces, a silent witness to the violence that might have birthed Hoag's perfect ring. Yet there's no obvious stellar debris left behind, no stars trailing these gaseous whispers to confirm the merger theory. That's led others to propose an even more intriguing possibility. What if this hydrogen is primordial, ancient gas falling into the galaxy for the first time, like rain condensing onto a leaf? The distribution of these filaments adds another layer of mystery. They're not scattered randomly but clustered in specific arcs, almost as if tracing the invisible gravitational scaffolding of dark matter. Some astronomers speculate they could be cold flows, streams of gas siphoned from the cosmic web itself, fueling Hoag's object from the outside in. But if that's the case, why haven't these filaments collapsed into new stars? Their persistence suggests something. Perhaps magnetic fields or subtle turbulence is keeping them suspended in this ghostly state. Then there's the puzzle of their motion. Unlike the galaxy's orderly rotation, these filaments move erratically, some drifting inward while others seem to resist the pull of gravity entirely. It's as if Hoag's object is still digesting a meal from billions of years ago, or perhaps these strands are the first threads of a new structure slowly knitting itself into place. Whatever their origin, one thing's certain: these faint hydrogen traces are more than just cosmic afterthoughts. They're a hidden narrative written in the faintest ink of the universe, waiting to be decoded. At the center of Hoag's object, something quietly defies expectations once again. While the galaxy's iconic ring spins gracefully in one direction, recent observations suggest the core might be doing the exact opposite, rotating backward like a cosmic rebel. If confirmed, this counter-rotation would be more than just a quirk. It'd be a glaring clue pointing to violent events in the galaxy's past. Picture this: two galaxies entwined in a gravitational dance billions of years ago. As one spirals into the other, their opposing spins could have cancelled each other out, leaving behind a core spinning in the opposite direction of its new ring. This kind of rare merger would explain the contradiction neatly, like a record spinning clockwise while its label turns counterclockwise. But here's the catch: Hoag's object shows no other signs of such a dramatic collision. No distorted remnants, no stellar debris, just this silent, discordant motion at its heart. Another possibility: the core might have stolen its backward spin from somewhere else. Gas clouds or even an entire dwarf galaxy, funneled inward over eons, could have delivered enough angular momentum to reverse the core's rotation gradually. This stealthy theft would leave fewer traces than a full merger, but still raises questions: why hasn't friction or time smoothed out the contradiction? Then there's the wild card: what if the core didn't reverse at all? Some researchers argue we might be seeing an illusion, an off-kilter bulge or warped disk masquerading as counter-rotation. It wouldn't be the first time perspective played tricks on astronomers. But if the evidence holds, this celestial tug-of-war would force us to reconsider not just Hoag's object's history, but how galaxies negotiate their identities after cosmic encounters. Whether it's a fossil of an ancient crash or a slow-motion heist, one thing's clear: this counter-rotating core doesn't just break the rules, it forces us to ask whether we wrote them correctly in the first place. One of the most baffling absences in Hoag's object isn't something within the galaxy, it's what should be around it. Every large galaxy we've ever studied, from Andromeda to our own Milky Way, is surrounded by an entourage of smaller dwarf galaxies, cosmic satellites gravitationally bound to their larger host. But Hoag's object stands alone. No faint companions circle it, no stellar stragglers cling to its edges. It's a cosmic monarch without a court, and that silence speaks volumes. The leading theory suggests a brutal past. Perhaps Hoag's object did have satellite galaxies once, but over billions of years it consumed them entirely. Their stars and gas would have been torn apart and assimilated, leaving no trace except for subtle chemical fingerprints in the ring or core. Yet even that idea hits a snag. Galactic cannibalism leaves behind messy stellar streams and distorted orbits, and Hoag's object shows none of those scars. Its structure is too pristine, too undisturbed, as if it never endured the gravitational tug of war that should have marked such feasts. That leaves an even stranger possibility. What if Hoag's object never had satellites to begin with? This would upend our understanding of galaxy formation, since current models rely on smaller galaxies merging and clumping together over time. A lone giant like this shouldn't exist unless it formed under freakishly quiet conditions, perhaps in a sparse pocket of the universe where dark matter's scaffolding failed to birth smaller companions. Some researchers propose a third option. Maybe the missing satellites are still out there, but they're invisible to our telescopes. Ultra-faint dwarf galaxies, made mostly of dark matter with just a handful of stars, could lurk unseen in Hoag's object's halo. But so far, searches have turned up nothing. Until we spot them or confirm their absence, this galactic solitude remains one of Hoag's object's most profound puzzles. Because in a universe built on collisions and companionship, a galaxy without neighbors isn't just unusual. It's a cosmic rebel daring us to rethink how giants are born. Amid the serene glow of Hoag's object's ring, certain regions burn with an invisible fury, ultraviolet hotspots so intense they outshine the rest of the galaxy in wavelengths our eyes can't see. These aren't just bright patches, they're cosmic furnaces where stars are being forged at a breakneck pace, each one a maelstrom of newborn suns scorching their surroundings with blistering radiation. The uneven distribution of these UV powerhouses is the real puzzle. Why do some sections of the ring ignite with such ferocity while others remain relatively quiet? One clue lies in the way gas behaves under extreme conditions. Dense pockets of hydrogen, compressed by shock waves or gravitational nudges, collapse into these frenzied star-forming zones. But what triggers those collapses isn't uniform. Some hotspots align with faint distortions in the ring's structure, hinting at past interactions with unseen celestial objects. Others seem to follow an almost rhythmic pattern, as if the ring itself has resonant points where star formation naturally amplifies. Another piece of the puzzle involves metallicity. The hottest UV regions often coincide with areas richer in heavier elements, suggesting earlier generations of stars seeded these zones with the raw materials for fiercer burning. It's a feedback loop. Each wave of star death dumps more metals into the mix, fueling even more explosive births in the next cycle. Yet even that doesn't fully explain the stark contrasts between neighboring regions. Then there's the wild card, turbulence. Simulations show that magnetic fields or chaotic gas flows could create isolated cauldrons of activity, like whirlpools in a river concentrating debris in unpredictable patches. If true, these UV hotspots aren't just anomalies, they're cosmic pressure valves, releasing the galaxy's pent-up energy in sporadic, dazzling bursts. Whatever the cause, their existence forces us to confront a humbling truth. Even in a structure as balanced as Hoag's object, chaos finds a way to carve its own signature into the stars. Hidden within Hoag's object's shimmering ring, pockets of extreme energy flicker like cosmic warning lights, powerful X-ray sources that defy simple explanation. These aren't your typical stellar emissions, they're violent outbursts, some so intense they outshine entire star clusters in high-energy wavelengths. The leading suspects, rogue black holes or neutron stars, lurking unseen as they rip material from nearby companions, heating it to millions of degrees until it screams across the electromagnetic spectrum. But here's what's odd, these X-ray hotspots aren't distributed randomly. They cluster in specific arcs of the ring, almost as if drawn there by some unseen force. If they were remnants of supernova, we'd expect them scattered more evenly, yet their precise arrangement hints at something more deliberate. One compelling theory suggests they might be the corpses of massive stars born in an earlier wave of star formation, now locked in tight binary systems where they slowly devour their partners. The real puzzle is their brightness variability. Some flare unpredictably, flickering like candles in a cosmic wind, while others emit steady, searing radiation. This inconsistency fuels debates. Could these be ultraluminous X-ray sources, rare objects where intermediate mass black holes gorge on gas at unprecedented rates? Or perhaps exotic pulsars, their magnetic fields so strong they twist spacetime itself into an X-ray beacon? What's undeniable is that these high-energy mysteries add another layer to Hoag's Object's enigma. Their very existence suggests violent chapters woven into the galaxy's seemingly serene story, episodes where chaos briefly flared before settling back into that perfect ring. And until we pinpoint their true nature, they'll remain both clues and conundrums, reminding us that even the most beautiful galaxies hide predators in their starlight. Scattered around Hoag's object like a carefully arranged cosmic necklace, its globular clusters defy the chaotic norm. These dense balls of ancient stars usually orbit galaxies in random, haphazard swarms, yet here, they've aligned themselves with uncanny precision, tracing the same flat plane as the galaxy's iconic ring. It's as if some unseen hand lined them up deliberately, turning what should be a chaotic stellar swarm into a synchronized celestial ballet. This bizarre alignment challenges our understanding of how globular clusters form. Most galaxies accumulate these clusters over billions of years through mergers and captures, leaving them scattered in every direction. But Hoag's Object's clusters seem to follow a hidden blueprint, one that suggests they either formed alongside the ring or were funneled into this orderly arrangement by forces we've yet to unravel. One compelling theory points to the galaxy's unique structure. The same gravitational forces that sculpted the ring might have shepherded these clusters into alignment, like leaves caught in a whirlpool settling into concentric circles. Alternatively, they could be remnants of a long-lost satellite galaxy torn apart by tidal forces, its clusters captured and coaxed into this strange new orbit. The real puzzle lies in their stability. Normally, such tight alignment would be fleeting gravitational nudges from passing galaxies or dark matter clumps should disrupt it over time. Yet these clusters have maintained their precise configuration for eons, hinting at some unseen mechanism locking them in place. Could dark matter's invisible grip be shaping their paths, or are we witnessing the aftermath of a rare, perfectly balanced galactic collision, one that left no other traces except this eerie symmetry? Every aligned cluster is more than just a cosmic oddity. It's a silent witness to forces we're only beginning to map, and as astronomers study their precise orbits, they're left with a humbling realization. Even the oldest objects in the universe can still surprise us, revealing patterns where we least expect them. Faint as whispers against the blackness of space, ethereal streams of stars spiral around Hoag's Object, filigree thin remnants of ancient cosmic feasts. These ghostly trails are more than just debris. They're forensic evidence revealing a past far more violent than the galaxy's serene appearance suggests. While Hoag's Object now floats like a perfect cosmic jewel, these stellar streams tell a different story, one of collisions, disruptions, and galactic mergers that should have left it misshapen. Yet here it stands, its secrets preserved in these fading stellar fingerprints. The streams curve in delicate arcs, tracing the orbits of long-vanished dwarf galaxies torn apart by Hoag's Object's gravity. Their stars move in unison, still clinging to the momentum of their lost homes billions of years later. By mapping their paths, astronomers can reconstruct the galaxy's hidden menu, what it consumed when it feasted, even how those meals might have shaped its iconic ring. One prominent stream, dubbed the Silent Ribbon, arcs high above the ring's plane, suggesting a dramatic, oblique collision that flung stars far from their original orbits. But the real mystery lies in how sparse these streams are. Most large galaxies like our Milky Way are surrounded by dozens of such remnants, their histories written in stellar spaghetti. Hoag's object, by contrast, shows only a handful. Were its mergers unusually clean, leaving little behind, or did something, perhaps its dark matter halo, scatter or erase the evidence more thoroughly than expected? The composition of these stars adds another twist. Some streams are richer in heavy elements than others, hinting they came from galaxies with wildly different life stories before being absorbed. A few even contain stars older than Hoag's object itself, cosmic immigrants from a time before the ring took shape. Yet despite this violent backstory, the galaxy now radiates order, as if it smoothed away the chaos like a pond settling after a stone's toss. These streams aren't just relics, they're proof that even the universe's most perfect structures are forged in turbulence. The ring of Hoag's object may appear flawless from a distance, but zoom in closer and you'll spot something startling. Knots of frenzied activity where the galaxy's orderly structure seems to unravel. These tangled regions, dubbed ring knots, are cosmic pressure cookers where gas clouds collapse in chaotic bursts of star formation, defying the serenity of their surroundings. Unlike the rest of the ring's measured elegance, these knots crackle with raw energy, birthing stars at rates that would dwarf entire stellar nurseries in our own Milky Way. The question isn't just why they exist, it's whether they're fleeting sparks or enduring fixtures. Some astronomers argue these are temporary firestorms, ignited by passing shock waves or gravitational nudges that will eventually burn themselves out. Others see them as self-sustaining engines, their turbulence continuously recycling gas into new stars for eons. The evidence is tantalizingly mixed. In some knots, younger stars dominate, suggesting recent ignition, while others harbor older stellar populations, hinting at a cyclical process that's persisted far longer than expected. What's truly puzzling is their distribution. These knots aren't scattered randomly but clustered in tight groups, almost as if the ring itself has weak points where instability naturally festers. Simulations suggest magnetic fields or dark matter interactions could be funneling gas into these specific zones, creating pockets of perpetual chaos. Yet that raises another mystery. If the knots are long-lived, why hasn't their energy disrupted the ring's perfect symmetry? It's like watching a pot of water boil violently in one corner while the rest remains eerily still. The stakes are higher than they seem. If these knots are indeed persistent, they could be the key to understanding how ring galaxies refuel themselves over cosmic time. Their violence might not be destruction but rebirth, a vital process stitching new stars into the galaxy's fabric. And if they're fleeting, then Hoag's object is even more extraordinary, maintaining its balance despite these sporadic eruptions. Either way, these unruly knots remind us that even the universe's most pristine structures are forged in the fire of rebellion. At the heart of Hoag's object, where other galaxies might hide a supermassive black hole, the core emits a light signature unlike anything astronomers anticipated. When its spectrum is stretched out like a cosmic barcode, strange emission lines flicker where none should exist, peculiar spikes of energy that reveal processes defying textbook explanations. These aren't the usual markers of star formation or black hole accretion. Instead, they hint at something far more exotic, a rare breed of nuclear activity or a population of stars living out their lives in ways we've scarcely documented. One leading theory points to a hidden engine, not a black hole, but a dense cluster of massive stars nearing the end of their lives. As these giants shed their outer layers in furious stellar winds, their ionized gas could be producing the unusual spectral lines. The core's brightness supports this idea, but there's a catch. The emission lines are too narrow, too controlled for the chaos expected from such volatile stars. Another possibility is a phenomenon called a low ionization nuclear emission line region, LINER for short. These are faint, enigmatic zones where gas glows not from furious feeding black holes, but from subtler processes like shockwaves or aging star clusters. Yet even among liner, Hoag's Object's core stands out. Its spectral fingerprints suggest a unique cocktail of elements, with some lines indicating highly ionized oxygen, something typically seen in far more violent environments. The most tantalizing clue lies in the absence of broad hydrogen lines, which usually betray the presence of an active supermassive black hole. Here, they're conspicuously missing, reinforcing the idea that Hoag's Object's core dances to a different tune entirely. Could this be evidence of a new galactic phase, one where nuclear activity flickers softly instead of roaring? Or is it a cosmic clock quietly counting down to a future eruption? For now, the spectrum remains a cipher, a silent broadcast from a core that refuses to fit the mold. Hidden within the delicate swirls of Hoag's Object's ring, a powerful force silently shapes its destiny, not gravity but magnetism. Recent radio telescope observations reveal something startling. The ring is threaded with organized magnetic fields, their strength far exceeding what's typical for a galaxy of this type. These invisible lines of force don't just meander randomly, they align with the ring's structure like cosmic stitching, reinforcing its flawless symmetry against the chaos of space. The strength of these fields is the first clue to their role. Most galaxies show tangled, weak magnetism, but here the fields are both coherent and intense, strong enough to influence how gas moves and where stars form. Astronomers suspect they act like an invisible scaffold, preventing turbulent clouds from straying too far and keeping the ring's edges crisp over billions of years. Picture a sculptor using fine wires to shape molten glass. These magnetic fields could be doing the same for the galaxy's star-studded band, but how did they get so strong? One theory suggests the ring's rapid star formation is key. As massive stars ignite and die, their explosive winds and supernova inject energy into the surrounding gas, amplifying and organizing magnetic fields in the process. Over time, this cycle could have woven the current network of force lines, turning the entire ring into a magnetized powerhouse. There's another tantalizing possibility. The fields might be primordial, frozen into the galaxy's structure since its formation. If true, they'd be a rare relic from the universe's youth preserved in this cosmic time capsule. Whatever their origin, one thing's clear: these magnetic fields aren't just bystanders. They're active players in Hoag's Object's enduring mystery, quietly defying the universe's tendency toward disorder. And that makes them more than invisible lines, they're the silent architects of perfection. While most ring galaxies shimmer with vast reservoirs of neutral hydrogen gas, the raw fuel for star formation, Hoag's Object stands as a stark exception. This invisible hydrogen, detectable only through radio telescopes, should be abundant in a structure like this, yet scans reveal a puzzling void where it ought to be. Other ring galaxies, like the Cartwheel or NGC 7020, brim with this primordial gas, their rings alight with ongoing stellar births. So why is Hoag's Object different? One possibility is cosmic theft, an ancient encounter where another galaxy or intergalactic wind ripped the hydrogen away. Gravitational interactions can strip gas from galaxies like leaves torn by a storm, leaving behind only the stars. But if that happened here, the event was remarkably clean. No twisted debris trails or distorted orbits remain as evidence, just this eerie absence where the gas should be. Alternatively, Hoag's Object might have been born without it. Some theories suggest it formed in an unusually dry environment, a region of space already depleted of neutral hydrogen before the galaxy took shape. Without this fuel, the galaxy's star-forming history would have been starkly different, perhaps explaining why its ring burns with such precise, sporadic intensity instead of a steady glow. Then there's the wildcard conversion. Over billions of years, the hydrogen could have been entirely processed into stars or ionized by radiation, transformed into a state our telescopes can no longer trace. If true, it would mean Hoag's object burned through its reserves with astonishing efficiency, leaving no trace of its original stockpile. Whatever the explanation, this missing hydrogen isn't just a footnote, it's a glaring clue. In a universe where gas is the currency of creation, Hoag's object seems to have rewritten the rules of cosmic economics, and without it, the galaxy's serene beauty becomes even more mysterious, a masterpiece painted with invisible brushstrokes. Among the swirling starlight of Hoag's object's ring, several dense clumps stand out, not just as star-forming regions but as potential galaxies in the making. These knot-like structures, rich with gas and newborn stars, could be tidal dwarf candidates, celestial infants born from the galaxy's own discarded material. Unlike typical galaxies forged from primordial gas, these would arise from the aftermath of cosmic collisions, sculpted by gravity from the debris of ancient encounters. The evidence lies in their composition. These clumps boast their own independent rotation, with stellar populations slightly older than the surrounding ring, hinting they might have formed earlier from ejected material. Some even show hints of dark matter, a key ingredient for galactic survival. If confirmed, they'd join a rare class of objects, galaxies birthed not from the Big Bang's aftermath, but from the wreckage of later cosmic violence. But their fate hangs in the balance. Without enough mass to fully escape Hoag's object's gravitational pull, they may eventually spiral back, merging into the ring like raindrops rejoining a pond. Alternatively, if they're flung outward with enough momentum, they could break free entirely, destined to roam the universe as true orphans of their parent galaxy. The debate centers on their longevity. True tidal dwarfs can persist for billions of years, but many are doomed to be reabsorbed. In Hoag's object's case, the pristine ring offers few signs of past disruptions, so if these candidates are genuine dwarfs, their origins must trace back to a collision so ancient its scars have nearly faded. Whether they'll endure or vanish, their existence blurs the line between galactic wreckage and new beginnings, proof that even in destruction, the universe finds ways to create. At the heart of Hoag's object, where most galaxies would host a monolithic swarm of ancient stars, the core tells a different story, one of unexpected diversity. Here, young blue stars mingle with grizzled red giants in a cosmic dance that shouldn't be possible. Galactic cores are supposed to be retirement homes for aging stars, yet this one pulses with youthful energy alongside its elders, like a vibrant city square where children play in the shadows of medieval towers. The presence of young stars here is the first puzzle. Normally, a galaxy's core is too dense for fresh star formation. Gravitational turbulence and intense radiation would shred gas clouds before they could collapse. Yet somehow, Hoag's object center defies the odds, cradling stellar newborns less than 100 million years old. One theory suggests a delayed ignition. Vast reservoirs of gas might have lingered here for billions of years, shielded from collapse until recent cosmic triggers, perhaps subtle density waves or magnetic instabilities, sparked a late burst of creation. The old stars are no less mysterious. Their chemistry reveals a surprising twist. Many are richer in heavy elements than expected, as if the core experienced multiple waves of star birth and death long before the current youngsters arrived. This layered history implies the galaxy didn't form in a single, monolithic collapse but through staggered episodes, each generation enriching the next with recycled stardust. Stranger still is their motion. While the older stars orbit sedately, some younger ones race on eccentric paths, hinting at violent origins perhaps born from shredded gas clouds flung inward during ancient collisions. Yet there's no visible wreckage to confirm the chaos. It's as if the core reset itself, smoothing away the scars while preserving the evidence in its stellar sensors. This hybrid population isn't just a curiosity, it's a living timeline. By studying its stars, we're glimpsing chapters of Hoag's object's past that its serene exterior tries hard to conceal. And every mismatched pair of stars whispers the same question. How many times has this galaxy rewritten its own story? Tucked away in the swirling starlight of Hoag's Object's ring, rapid-fire radio pulses flicker like cosmic lighthouses, potential beacons from dead stars spinning at dizzying speeds. These elusive signals, known as pulsar candidates, could rewrite our understanding of the ring's violent history. If confirmed, each one would mark the tombstone of a massive star that lived fast, died young, and left behind a supernova's legacy, a neutron star so dense it packs the sun's mass into a city-sized sphere, rotating hundreds of times per second. But confirming these candidates is like listening for whispers in a hurricane. The ring's dense star-forming regions create a cacophony of radio noise, making it nearly impossible to isolate the telltale rhythmic pulses of a true pulsar. Compounding the challenge, many of these signals are intermittent, flaring unpredictably before vanishing for months or years, leaving astronomers chasing ghosts in the data. The stakes are higher than they seem. Pulsars are forensic tools. The more found in a region, the more supernova must have occurred there. Hoag's Object's ring, with its blue star clusters and UV hotspots, already hints at frenzied stellar births and deaths. A population of pulsars would cement the case, revealing that beneath its perfect symmetry lies a graveyard of exploded giants. Even more intriguing, their distribution could map where the most massive stars once thrived, exposing hidden patterns in the ring's turbulent past. For now, these flickering signals remain tantalizing maybes, the cosmic equivalent of a shadow glimpsed from the corner of your eye. But if even one is verified, it would be a smoking gun, proving that Hoag's Object's serene beauty is a mask, concealing a history of stellar cataclysms that shaped its evolution. Until then, astronomers keep listening, tuning their telescopes to the faintest rhythms of the dead. For a galaxy that appears so perfectly symmetrical in visible light, Hoag's Object hides a striking secret when viewed through radio telescopes, uneven bursts of energy flaring from one side like a cosmic heartbeat gone arrhythmic. These lopsided radio emissions paint a picture of something deeply unbalanced happening beneath the serene surface. While the ring gleams with orderly starlight, the galaxy's invisible radio signature crackles with asymmetry, as if half of it is whispering while the other half shouts. The leading suspect, hidden activity in the core. Most galaxies emit radio waves symmetrically, often fueled by twin jets blasting from a central black hole. But here, the emissions skew dramatically toward one side, suggesting either a one-sided jet or sporadic accretion events, violent feasts where matter spirals into a dense object, releasing energy in uneven bursts. The odd part, Hoag's Object isn't supposed to have the kind of active core that produces such energetic outbursts. Its visible light shows no signs of disruption, leaving astronomers to wonder, is there a stealthy engine at work, flickering on and off without leaving the usual traces? Another possibility involves the ring itself. The blue star clusters on one side might be generating more intense stellar winds and supernova, their combined chaos amplifying radio emissions in that region. Yet the scale of the asymmetry is too vast for stars alone to explain. These radio waves carry the fingerprint of something far more powerful, something hidden. The truth might lie in the galaxy's past. If Hoag's Object formed from a lopsided collision or merger, residual turbulence could still be echoing through its structure, stirring uneven activity even billions of years later. Whatever the cause, this radio imbalance proves that even the most flawless-looking galaxies are never quite what they seem. The universe, it seems, has a fondness for imperfections, especially when they defy our expectations. Deep within the dust-shrouded lanes of Hoag's Object's ring, something lurks, unseen clusters of stars so veiled by cosmic debris they're completely invisible to optical telescopes. These are the dark star clusters, ghostly gatherings revealed only by their telltale infrared glow, where thick curtains of dust absorb starlight and re-emit it as heat. Unlike their glittering blue counterparts in the ring, these clusters hide in the shadows, their true nature obscured but no less fascinating. Infrared observations paint a surreal picture. Dense knots of stars buried under blankets of dust, likely older and cooler than the young, blazing clusters nearby. The dust isn't just a veil, it's a time capsule. These clusters might be relics from an earlier era, their stars born in a burst of activity that's since faded, leaving behind only these dim, smothered remnants. Or perhaps they're still forming, their natal gas and dust so thick that new stars ignite in secrecy, shielded from view until they blow away their dusty cocoons. What's startling is how different their environment must be. While visible clusters bask in open space, these dust-bound groups likely endure extreme conditions, scorching radiation trapped by the dust, chaotic magnetic fields, and intense pressure from collapsing gas. Some might even host unusual stellar hybrids, stars enriched by heavy elements from earlier supernova, their chemistry altered by the dense surroundings. The real mystery is why they're here at all. Most galaxies disperse dust over time, but Hoag's object seems to have preserved or regenerated these murky pockets like cosmic vaults. Whether they're ancient survivors or newborn stellar nurseries, one thing's clear: the galaxy's pristine ring hides more than just beauty. It shelters secrets written in dust and heat, waiting for the right tools and the right questions to reveal them. Peering closely at Hoag's object's ring reveals a hidden dance. Its stars don't move in unison like a rigid wheel, but slip past each other in a cosmic game of tug-of-war. This phenomenon, called shear, creates streaks of differential motion where inner regions spin faster than outer ones, stretching the galaxy's fabric like taffy. The effect isn't just aesthetic, it's reshaping the ring's destiny one stellar neighborhood at a time. Shear typically stifles star formation. Gas clouds get pulled apart before they can collapse into new suns. Yet here, against all odds, the ring's blue clusters blaze defiantly. The secret might lie in sheer scale. Hoag's object's vast dimensions could give nascent stars more time to coalesce before shear tears their nurseries apart, creating pockets where gravity still wins. Some regions even show evidence of localized resistance, with dense knots of gas anchoring themselves against the slipstream like boulders in a river. But the real surprise comes from the gas dynamics. Simulations suggest shear should funnel material into narrow streams, yet the ring's hydrogen appears in irregular clumps, as if some invisible force is bunching it up against the tide. Magnetic fields or dark matter interactions might be counteracting the shear's smoothing effect, creating temporary shelters where star formation ignites in sporadic bursts. The most tantalizing clue: the shear pattern isn't uniform. Certain arcs of the ring rotate almost cohesively, while adjacent zones churn with turbulence. This patchwork motion hints at a history written in stages, perhaps multiple collisions or mergers, each leaving behind a distinct imprint on the galaxy's spin. It's a reminder that even the most serene celestial structures are, beneath the surface, archives of cosmic violence where every twist in the starlight tells a story. Among the many mysteries of Hoag's object, one of the most subtle yet revealing lies at its very heart: a flicker. Over months and years of observation, astronomers have detected tiny but measurable shifts in the core's brightness, as if something deep within is pulsing with quiet instability. These variations are minute, barely a ripple in the grand glow of the galaxy's center, but their existence raises a tantalizing question: what cosmic engine could be causing this rhythmic dimming and brightening? The most dramatic explanation points to a microquasar, a miniature version of the quasars that blaze from the centers of active galaxies. Unlike their gargantuan cousins, microquasars are compact systems where a stellar mass black hole or neutron star feeds on material stripped from a companion star. As gas spirals inward, it heats up, emitting bursts of energy before plunging into darkness. If one of these cosmic dynamos lurks in Hoag's object's core, Its flickering light could hint at sporadic feasting, with brightness flaring each time a fresh clump of matter falls toward oblivion. Not all astronomers are convinced. Some argue the variations could stem from an unstable accretion disk, a swirling maelstrom of gas and dust struggling to find equilibrium. Normally, such disks around supermassive black holes glow steadily, but if the flow of material is uneven, clumpy, or turbulent, the brightness might waver like a candle in a draft. The catch: Hoag's object isn't supposed to have a supermassive black hole at all, at least not one we've detected, unless, of course, it's hiding a stealthy one, cloaked in darkness and only betraying its presence through these tiny fluctuations. A third possibility is even stranger. What if the flickering comes not from a single object but from a synchronized dance of massive stars? In dense stellar environments, multiple stars nearing the ends of their lives could erupt in overlapping waves of activity, supernova, stellar winds, or collisions, creating a pattern of flickers that mimics a single source. It's a cosmic sleight of hand where the galaxy's core might be disguising its true nature behind a veil of starlight. Whatever the cause, these subtle variations are more than just quirks, they're clues. In a universe where stability often means stagnation, Hoag's object's flickering heart reminds us that even the most serene galaxies harbor hidden turbulence. And as astronomers continue to monitor its rhythm, they're listening for the whispers of forces we've yet to name. Drifting along the outer fringes of Hoag's object, nearly invisible against the void, float enigmatic banks of gas moving at breakneck speeds, cosmic nomads with uncertain origins. These high-velocity clouds streak through the galaxy's halo, some plummeting inward while others race outward, as if caught in a celestial tug of war. Their trajectories present a paradox. Are these clouds fresh fuel falling in to feed future star formation, or the scattered debris of ancient galactic explosions? One camp argues for accretion, the idea that these clouds are intergalactic gas, drawn in by Hoag's object's gravity like moths to a flame. If true, they could be remnants of the cosmic web, primordial material left over from the universe's infancy, finally reaching the galaxy after billions of years adrift. Their composition holds clues. Some show lower metal content, typical of pristine gas untouched by stellar furnaces, yet others point to the clouds racing away as evidence of a dramatic past. Supernova or intense radiation from the ring's young stars could have blasted these gas streams outward, creating a galactic fountain where ejected material eventually rains back down. A few clouds even show signs of turbulence, their shapes twisted as if recoiling from some long-ago eruption. The most tantalizing possibility: both theories might be right. Hoag's object could exist in a delicate balance, siphoning fresh gas from the cosmos while simultaneously shedding its own. This cycle would make it a galactic breather, inhaling and exhaling material across eons. Until we trace these clouds' paths more precisely, their true story remains written in motion, half falling, half fleeing, and utterly defiant of simple explanation. While the visible light from Hoag's object paints a picture of cosmic perfection, its infrared glow tells a far stranger story. Scattered across the ring, bizarre spectral signatures flicker like alien Morse code patterns of light that don't match any known element or simple molecule. Dubbed unidentified infrared features, these mysterious emissions have become one of the galaxy's most tantalizing puzzles. At first glance, they resemble the chemical fingerprints of complex organic molecules, the kind that form in stellar winds or comet tails. But the wavelengths are subtly off, shifted in ways that suggest environments unlike anything we've seen in our own galaxy. Some researchers speculate they could be exotic carbon-based compounds forged under extreme conditions, their atoms arranged into unusual configurations by the ring's unique pressures and radiation. Imagine diamonds forming in a hurricane. That's the level of cosmic alchemy we might be witnessing. Another camp points to something even more extraordinary. These infrared signatures could trace back to nanoparticles, tiny stardust grains coated in frozen hydrocarbons. When bathed in ultraviolet light from nearby stars, these motes might emit distorted infrared echoes like microscopic tuning forks vibrating at frequencies we've never recorded before. What makes this idea so compelling is how it ties into the ring star-forming frenzy. The same violent bursts that light up Hoag's object with blue clusters could be superheating these dust grains, making them glow in these peculiar ways. Yet the most intriguing possibility involves chemistry we haven't even named yet. The ring's perfect symmetry creates gravitational eddies and radiation zones unlike anywhere else in the universe, conditions ripe for molecules to form in ways that defy our laboratories. If proven, these infrared mysteries wouldn't just be curiosities. They'd be a whole new chapter in astrophysics, written in the faint heat of a galaxy determined to keep surprising us. Every unexplained wavelength is a whisper from the universe's hidden recipe book, and Hoag's object seems eager to share secrets we're only beginning to decode. Spanning the luminous ring of Hoag's object like a cosmic rainbow, an unexpected color gradient unfolds, vibrant blue near the inner edge, fading to deep crimson at the outer rim. This subtle shift in hue isn't just aesthetic, it's a timeline written in starlight, revealing how the galaxy has evolved over billions of years. The blazing blue inner regions betray their youth, clusters of massive stars burning hot and fast, their short lives ending in supernova that seed the ring with heavy elements. Moving outward, the light reddens as older, cooler stars dominate, their bloated forms glowing like embers in the cosmic dark. But here's what's fascinating: this pattern defies expectations. Normally, galaxies show the opposite trend: older, redder populations huddle near the core, while younger blue stars radiate outward. The reversal tells a story of inside-out growth. One theory suggests the ring formed from a shockwave rippling outward, triggering star formation first along its inner edge before spreading to the periphery. Alternatively, gas density might have been higher toward the center, allowing stars to ignite earlier and faster there, while outer regions took longer to accumulate enough material. Even more revealing is the metallicity shift tied to these colors. Younger blue stars shine with higher concentrations of heavy elements, debris from generations of supernova that came before them. As we move outward, redder stars show fewer metals, hinting they formed from purer gas untouched by earlier stellar explosions. It's as if the ring's gradient freezes the galaxy's chemical evolution in place, a living museum of cosmic alchemy. But the real puzzle: some red giants lurk surprisingly close to the blue zones, their aged forms clashing with neighboring stellar newborns. Whether they're ancient stragglers or evidence of a paused star-forming cycle, their presence adds wrinkles to the timeline. Every shade in this celestial spectrum is a brushstroke in Hoag's object's self-portrait, one that's still being painted. At first glance, Hoag's object's core seems like a serene sphere of golden starlight, but zoom in closer and you'll notice something's off. The shape isn't a perfect circle, it's stretched slightly like an egg gently squeezed at the poles. This subtle elongation might seem insignificant, but in the cosmic rulebook, even minor deviations can signal seismic events. One explanation points to a dramatic past. If a smaller galaxy collided with Hoag's object long ago, the gravitational tug of war could have distorted the core, leaving it permanently warped. The intruder's gravity would have pulled stars outward like taffy before vanishing, leaving behind this faint fingerprint. Supporting this idea, computer simulations show that mergers often stretch galactic cores into oblong shapes, yet there's a catch. Most mergers leave behind telltale debris, stellar streams, clumpy orbits, or disturbed dust lanes. Hoag's object's core, by contrast, appears otherwise pristine, its stars orbiting smoothly despite the odd contour. Alternatively, the elongation might stem from internal chaos. Stars and gas swirling at different speeds can create instability, buckling the core into a lopsided form over time. Imagine a spinning pizza dough flinging edges outward, except here, gravity acts as the cosmic chef, shaping the core's edges into this subtle oval. Some astronomers even speculate that an unseen bar, a dense lane of stars, could be hiding in the core's heart, its gravitational influence stretching the surrounding stars like an invisible hand. But the most tantalizing clue lies in the core's rotation. If it's spinning just a fraction too fast, centrifugal force could naturally flatten it at the poles, explaining the elongation without invoking cataclysms. The trouble is, measuring that spin is fiendishly difficult from our vantage point. Whether it's a relic of ancient violence or a quirk of celestial mechanics, this off-kilter core proves that even the most tranquil galaxies hide quiet rebellions where every imperfection is a whisper of untold history. One of the strangest absences in Hoag's object isn't something present, it's what should be there but isn't. Planetary nebulae, those glowing shells of gas expelled by dying stars, are conspicuously scarce in the galaxy's vibrant ring. These cosmic death shrouds are common in most galaxies, especially in star-rich regions like this. So where are they hiding? The numbers don't add up. Given the ring's abundance of massive stars, many nearing the end of their lives, we'd expect dozens of these glowing relics, yet only a handful have been tentatively detected, their faint signatures drowned out by the brilliance of younger neighbors. One possibility is observational bias. Perhaps their delicate structures are simply overshadowed by the ring's dazzling blue clusters. But even with advanced telescopes scouring the region, they remain stubbornly elusive. Another theory suggests an environmental quirk. Planetary nebulae require specific conditions to form and stay visible, enough gas to glow, but not so much that it disperses too quickly. Hoag's object's ring might be too turbulent, its fierce stellar winds shredding these fragile bubbles before they can fully illuminate. Or perhaps the metallicity plays a role. If the stars here lack certain heavy elements, their death throes could produce fainter, shorter-lived nebulae. The most unsettling idea, the nebulae did exist but vanished faster than expected. Some models predict that in dense stellar environments, radiation from nearby stars can ionize and dissolve planetary nebulae in mere thousands of years, a blink in cosmic time. If true, Hoag's object's ring could be a graveyard with no tombstones, its deceased stars leaving no visible trace behind. Whatever the reason, this absence isn't just a curiosity, it's a clue. In a universe where death is often as luminous as life, Hoag's object's missing nebulae force us to ask, are we seeing a galactic anomaly, or just how little we truly understand about stellar farewells? At first glance, Hoag's object's ring appears flawlessly smooth, a pristine circle of starlight floating in the void. But look closer, and faint irregularities emerge like hairline cracks in a masterpiece. These barely visible fractures curve through the ring's structure, some snaking inward while others branch outward like cosmic lightning. Their presence raises a tantalizing question. Are we seeing the aftermath of a forgotten collision, or signs of the ring slowly unraveling from within? One clue lies in their shape. Some fractures align with the paths that tidal forces would take the gravitational stretch marks left if a smaller galaxy once sideswiped Hoag's object. Yet there's no debris trail, no trail of stellar breadcrumbs leading back to a culprit. That absence has led astronomers to consider a more subtle explanation. Maybe these are stress fractures born from the ring's OWN Chinese letter dynamics. Picture a spinning vinyl record developing tiny warps over time. The ring's perfect symmetry might be buckling under its own momentum, its stars and gas tugging against each other in delicate rebellion. The fracture's distribution adds another layer of intrigue. They're not scattered randomly but cluster in specific quadrants, as if tracing fault lines in an invisible tectonic plate. This pattern suggests something deeper at work. Perhaps resonances with the galaxy's dark matter halo, or remnants of a past spiral structure that failed to fully unwind. Then there's the wild card. What if these aren't fractures at all? Advanced simulations show that dense star-forming regions can cast long shadows of gravitational influence, warping nearby starlight into shapes that mimic cracks. In this scenario, the fractures would actually be illusions, side effects of the ring's most violent stellar nurseries bending space-time like funhouse mirrors. Whether they are scars, stresses, or cosmic sleights of hand, these subtle breaks in perfection remind us that even the universe's most balanced structures harbor hidden tensions. And for astronomers, every irregularity is a breadcrumb trail leading closer to understanding how celestial harmony endures amid the chaos. Deep within Hoag's object's serene glow, the core hides a kinetic secret. Its stars march to the beat of their own cosmic drum. While the galaxy's iconic ring rotates with graceful unity, the core's stellar inhabitants move in stark defiance, spinning at a different speed and angle as if disconnected from the rest of the structure. Astronomers call this kinematic decoupling, and it's one of the clearest signs that the galaxy's heart operates by its own hidden rules. This independent motion points to something extraordinary. The core might not be a simple sphere of stars, but a second, embedded disk tucked inside the larger ring. Picture a spinning plate balanced on a larger turntable. Both rotate, but at their own tempo and tilt. If confirmed, this nested disk could explain the core's strange behavior, with its stars locked into a separate plane of motion shaped by ancient galactic drama. Theories diverge on how this dual system emerged. One camp argues for a long-ago merger, a smaller galaxy plunging through Hoag's object at just the right angle to leave behind a misaligned disk of stars. Others propose internal upheaval, where gas clouds collapsing at odd angles formed stars in this tilted dance. Supporting this idea, some stars in the core show chemical fingerprints distinct from the ring, hinting they might be cosmic immigrants from another place and time. Yet the most puzzling aspect is the disk's persistence. Galactic dynamics should have erased such a delicate structure over billions of years, smoothing it into the core's overall shape. The fact that it endures suggests something. Perhaps invisible dark matter or magnetic fields actively maintains this celestial tango. Whether relic or rebel, Hoag's object's decoupled core forces us to reconsider how galaxies preserve their secrets layer by surprising layer. Among the dazzling blue star clusters of Hoag's object's ring, a few red giants stand out not just for their age but for their bizarre chemistry. These aren't ordinary old stars. They're carbon monsters, their atmospheres choked with sooty carbon molecules that paint their light a deep, ruddy hue. What makes them truly perplexing is their location. They're nestled amid neighborhoods of stellar newborns, like ancient oak trees sprouting in a field of wildflowers. Carbon stars this rich shouldn't exist here. Normally, they form in aging stellar systems where multiple generations of stars have cycled through, polluting space with carbon forged in their cores. Yet Hoag's object's ring is supposed to be relatively young, its blue clusters blazing with the light of stars barely 100 million years old. So how did these carbon relicts end up stranded in a cosmic nursery? One radical theory suggests a cosmic shortcut. Perhaps some stars here were born with heavy carbon already baked in. Dense pockets of pre-enriched gas, laced with carbon from an earlier, unseen generation of stars, could have collapsed directly into these oddballs. It's like finding a fully baked loaf of bread in a bag of flour with no oven in sight. Others argue for stellar vampirism. Binary star systems might be at play, where an aging star steals material from a companion, dredging up carbon from its core and puffing it into its atmosphere prematurely. These stellar thieves would then masquerade as ancient giants despite being far younger than they appear. The most tantalizing possibility: these carbon stars could be cosmic hitchhikers, ancient wanderers captured from a dwarf galaxy that long ago dissolved into Hoag's object's ring. Their unique chemistry would be a dead giveaway, fingerprints from a lost stellar system now blended into this perfect ring. Whether they're imposters, intruders, or evidence of gaps in our stellar playbook, one thing's certain: these carbon anomalies are rewriting the rules of star formation, one sooty molecule at a time. While Hoag's object appears perfectly balanced at first glance, a closer look uncovers a hidden imbalance. The ring's eastern side weighs significantly more than the western side. This lopsided mass isn't just a minor quirk, it's a glaring clue that the galaxy's pristine symmetry might be an illusion. The dense eastern arc bristles with extra star clusters, gas clouds, and even a higher concentration of heavy elements, like a cosmic scale tipped by unseen hands. One explanation points to a violent past. Perhaps a dwarf galaxy sideswiped this region long ago, dumping its material into the ring before vanishing without a trace. If true, the collision's angle could explain why the debris piled up unevenly, leaving one side permanently weighted. Yet there's no obvious wreckage, no stellar streams trailing away, just this silent imbalance. Alternatively, the asymmetry might be self-inflicted. Turbulence in the galaxy's gas could have triggered a lopsided starburst, with one side igniting more fiercely than the other. Imagine a firework fuse burning unevenly, leaving half the powder unlit. Supporting this idea, the denser side shows signs of younger stars, suggesting a delayed but more intense wave of formation. But the real mystery is why the imbalance persists. Gravity should have smoothed out the differences over billions of years, yet the ring remains stubbornly uneven. Could dark matter be anchoring the extra mass in place? Or is the galaxy still settling from some ancient disturbance we've yet to detect? This cosmic imbalance isn't just a flaw in the design, it's a fingerprint pressed into the galaxy's skin by forces we're only beginning to trace. At the heart of Hoag's object, where most galaxies shine with the fierce ultraviolet glow of newborn stars, something unexpected emerges, a puzzling void of UV light. The core radiates significantly less high-energy radiation than models predict, as if someone dimmed the cosmic spotlight. This ultraviolet deficit isn't just a minor gap in the data. It's a glaring contradiction that challenges our assumptions about what fuels a galactic center. Normally, stellar nurseries bursting with massive young stars flood their surroundings with ultraviolet light. But here, the core's golden haze suggests a quieter reality, one where star formation has either slowed to a crawl or stopped entirely. One theory points to an unusual dust curtain. Thick clouds of cosmic debris might be absorbing that UV light before it escapes, effectively hiding the core's true activity. Yet infrared scans show no telltale heat signatures from such dust, leaving astronomers skeptical. Alternatively, the core could be in a dormant phase. Perhaps it exhausted its gas reserves long ago, leaving behind an aging population of stars that no longer produce intense UV emissions. This would make Hoag's object's core a cosmic retirement community, where once fiery giants now glowed gently, their youthful vigor faded. But that raises another question. Why hasn't fresh gas from the ring replenished the core over billions of years? A third, more radical idea suggests the deficit isn't about missing stars at all. Unusual magnetic fields or turbulence might be suppressing star formation entirely, creating a sterile zone at the galaxy's heart. If true, this would rewrite the rules of galactic evolution, proving that some cores can exist in a state of suspended animation, defying time itself. Whatever the cause, Hoag's object's UV silence speaks volumes. In a universe that thrives on creation and destruction, this eerily quiet core forces us to wonder, is it a relic of the past or a sign of something far stranger unfolding in the shadows? Tucked within the glowing bands of Hoag's object's ring, astronomers have stumbled upon something invisible yet ferocious, pulsating bursts of gamma rays, the universe's most energetic light. These detections aren't just faint whispers, they're the equivalent of cosmic fireworks, packing enough power to outshine entire star clusters in high-energy wavelengths. And their presence raises a tantalizing question. What could possibly generate such violent radiation in a galaxy that otherwise appears so serene? One leading suspect is the aftermath of cosmic ray collisions. When particles accelerated to near light speeds, perhaps by supernova shockwaves or spinning neutron stars slam into interstellar gas, they can produce gamma rays as a byproduct. In Hoag's Object's ring, where star formation is rampant, the sheer density of stellar explosions and turbulent gas could be fueling a gamma ray factory. Yet there's a hitch. The detected hotspots don't align perfectly with the most active star-forming regions, leaving gaps in the theory. That's where the darker explanation comes in. Some researchers speculate these gamma rays might be the death cries of dark matter particles. According to certain models, when these elusive particles collide, they could annihilate each other in bursts of high-energy radiation. If true, Hoag's Object's gamma rays would be the first tangible fingerprint of dark matter's hidden interactions, a smoking gun in one of astronomy's greatest mysteries. But proving it won't be easy. The signal is faint, tangled amid other cosmic noise, and competing explanations like hidden black holes or magnetized stellar remnants are just as plausible. The most intriguing clue lies in the gamma rays' distribution. Instead of being scattered randomly, they cluster in faint arcs, as if tracing the invisible scaffolding of something much larger. Whether they're the echoes of dark matter's demise or simply the fallout from stellar violence, one thing's clear. Hoag's Object's tranquil beauty conceals forces that crackle with the raw power of the cosmos itself. And every flicker of gamma light brings us closer to untangling the secrets woven into its perfect ring. One of the most mesmerizing discoveries about Hoag's Object isn't something you can see, it's something you could almost hear if the vacuum of space carried sound. The entire ring appears to vibrate, resonating like a colossal drumhead struck by an invisible hand. These harmonic oscillations aren't just poetic whimsy, they might be the galaxy's secret to maintaining its flawless symmetry across billions of turbulent years. Computer simulations reveal something extraordinary. As stars and gas clouds orbit within the ring, their collective gravity creates waves that ripple outward in precise, repeating patterns. Picture dropping a pebble into a pond, except here the waves don't fade. They bounce back from the ring's edges, interacting with new waves in a self-reinforcing dance. This delicate balance of motion could explain why the ring hasn't frayed or distorted over time. The oscillations act like cosmic shock absorbers, smoothing out disturbances before they can disrupt the galaxy's perfect form. But how does a structure this vast vibrate without flying apart? The answer lies in dark matter, the invisible gravitational glue holding everything together. Theorists suggest Hoag's Object's halo might be shaped just right to cradle these oscillations, its unseen mass acting like the rim of a drum, keeping the vibrations contained. Without it, the ring's delicate harmony would unravel into chaos. Not all researchers are convinced. Some argue these oscillations are too subtle to have such a profound effect, proposing instead that the ring's stability comes from its sheer size, like a spinning coin that stays upright longer the faster it turns. Yet the math holds up. When tuned precisely, these resonant waves could indeed counteract the natural tendency for galaxies to clump and warp over time. Whether it's dark matter's hidden hand or a rare cosmic rhythm, one thing's certain: Hoag's Object doesn't just look like a work of art. It moves like one too, its structure preserved not by stillness but by an eternal, silent song written in the language of gravity itself. At the heart of Hoag's Object, where the golden glow of ancient stars dominates, astronomers have uncovered something unexpected: delicate tendrils of cosmic dust weaving through the core like ghostly cobwebs. This discovery defies expectations because galaxies like this, with their serene and uniform centers, aren't supposed to harbor such intricate dust structures. These faint lanes shouldn't exist here, yet they spiral subtly through the core's light, whispering secrets about the galaxy's hidden past. The dust's presence raises immediate questions. In most similar galaxies, dust collects in predictable rings or disks, but here it forms intricate, almost chaotic patterns, more akin to tangled threads than orderly lanes. One leading explanation points to a recent, gentle merger. A tiny galaxy or gas cloud might have brushed past Hoag's object in the last few billion years, leaving behind these dust trails as the only remnants of its passage. The lack of other disturbances suggests the encounter was remarkably delicate, like a feather drifting through smoke, leaving barely a ripple. But there's another possibility: the dust could be homegrown. Intense radiation from aging stars in the core might have eroded ancient dust clouds into these wispy filaments, sculpting them over eons like sand dunes shaped by a steady wind. Supporting this idea, some lanes align with faint magnetic fields detected in the region, hinting that invisible forces could be shepherding the dust into these peculiar formations. The real puzzle lies in the dust's composition. Preliminary observations suggest it's richer in complex carbon compounds than expected, more like the sooty remnants of a forest fire than the pristine grains found in most galactic cores. Could this mean the core once hosted a burst of star formation intense enough to forge these unusual molecules? Or is the dust itself an intruder, carrying the chemical signature of a long-digested dwarf galaxy? Whatever their origin, these dust lanes are more than just cosmic lint. They're clues to a backstory the galaxy has tried hard to erase. And as astronomers trace their faint contours, they're left with a humbling thought. Even the most polished corners of the universe still hold traces of the chaos that shaped them. Among the glowing expanse of Hoag's Object's ring, something curious unfolds. Star formation doesn't ignite uniformly across its span. Instead, it crackles to life in sporadic pockets, leaving vast stretches gleaming but silent. This isn't random chaos. It's a cosmic balancing act where gas density and shockwaves conspire to create a star-forming recipe with very specific ingredients. The key lies in a critical threshold. For gas clouds to collapse into stars, they need to reach a density high enough to overcome internal pressure and radiation. Think of it like trying to start a campfire: too little kindling, and the flame flickers out. In Hoag's Object's ring, only certain regions accumulate enough gas to cross this tipping point, often where turbulent flows compress material into dense knots. These hotspots become stellar nurseries, while neighboring areas remain too diffused to ignite. But density alone doesn't tell the whole story. Shockwaves ripple through the ring, echoes of past collisions or gravitational nudges piling gas up like snow in front of a plow. When these waves intersect or reflect off the ring's structure, they create temporary zones of extreme pressure, squeezing gas past its breaking point. That sudden compression triggers cascades of star birth, explaining why active regions often cluster in arcs or spirals rather than scattering randomly. Here's where it gets even more intriguing. The ring's own rotation plays a role, stretching some gas clouds thin while bunching others together. Areas with slower shear where motion is more cohesive allow gravity to pull gas into stable clumps. Elsewhere, rapid differential rotation tears potential nurseries apart before they can fully form. It's a celestial Goldilocks scenario: too still and nothing ignites, too turbulent and everything scatters. Only in the narrow middle ground do stars emerge. This delicate interplay of forces means Hoag's Object's ring isn't just a static band of light. It's a dynamic engine, its star-forming rhythm dictated by invisible physics, where even the slightest shift in density or motion can mean the difference between a blazing stellar factory and a quiet cosmic desert. And in that imbalance lies a deeper truth: perfection in space isn't about uniformity. It's about the precise, fleeting conditions that let creation spark against the void. Astronomers have long considered molecular clouds the cosmic cradles of star formation, dense, frigid pockets where gas collapses under its own weight to ignite new suns. But in Hoag's Object's ring, these crucial nurseries are strangely sparse. Given the ring's vibrant blue clusters, you'd expect it to teem with these gas giants, yet scans reveal only faint whispers where roaring clouds should be. It's as if someone swept away the raw materials mid-construction, leaving behind only the finished stars. One compelling explanation points to the ring's own stellar offspring. Massive young stars blaze with ultraviolet radiation, their fierce winds capable of shredding nearby molecular clouds before they can fully coalesce. Picture a wildfire racing through a forest, leaving only charred gaps where trees once stood. If the ring's star-forming regions ignited in rapid bursts, their collective radiation might have sterilized the surrounding space, vaporizing potential nurseries before new stars could form. But there's a twist. Some simulations suggest magnetic fields could be the invisible sculptors. In most galaxies, molecular clouds cling to magnetic field lines like beads on a string, but Hoag's Object's unusually strong and organized magnetism might be disrupting this delicate balance. Instead of clumping into dense clouds, gas could be stretched into thinner filaments, too diffused to collapse into stars. It's a cosmic tug-of-war gravity trying to pull material together while magnetic forces keep it just out of reach. The most tantalizing clue lies in the distribution of the remaining molecular gas. What little exists appears in faint, thread-like structures, as if the clouds were unraveled by some relentless force. Whether it's radiation, magnetism, or a combination of both, their scarcity challenges our understanding of how galaxies sustain star formation over time. Without these dense reservoirs, Hoag's Object's ring shouldn't still be alight with young stars, and yet it is. That paradox alone makes these missing clouds one of the galaxy's quietest but most revealing mysteries. Deep within the tranquil glow of Hoag's Object's core, astronomers have uncovered a celestial ballet with an unexpected rhythm, stars pirouetting along boxy, rectangular orbits instead of the smooth ellipses seen in most galaxies. This isn't just a minor quirk, it's a fundamental challenge to how we think gravity shapes cosmic structures. Imagine a planetary system where planets moved in sharp zigzags rather than graceful curves. That's the level of anomaly we're dealing with here. These boxy orbits suggest something startling. The core's gravitational field isn't as uniform as models predict. In a typical galaxy, stars glide through a smooth, bowl-like potential, their paths rounded by predictable forces. But Hoag's Object's core behaves more like a maze, with hidden twists in its gravitational fabric nudging stars into these angular trajectories. One explanation points to an unseen stellar bar, a dense lane of stars stretched like a tightrope through the core's heart, warping orbits with its gravitational tug. Yet infrared scans show no obvious sign of such a structure, leaving theorists puzzled. Another possibility involves dark matter. If the galaxy's invisible halo is clumpier or more asymmetrical than assumed, its uneven pull could be shepherding stars into these jagged paths. Simulations reveal that certain dark matter distributions can create boxy orbital families, but none match Hoag's Object's pristine symmetry elsewhere. It's as if the core is whispering secrets about gravity that the ring refuses to acknowledge. The most tantalizing clue, some stars trace orbits that switch sharply between boxy and looped shapes, almost as if they're straddling two gravitational regimes. This duality hints at a transitional phase, a core caught between two states of equilibrium, its stars bouncing like pinballs in a cosmic machine we've yet to fully map. Every angular orbit is a breadcrumb leading us deeper into the question. When it comes to galactic mechanics, how much have we truly mastered? Nestled within the shimmering star clusters of Hoag's Object's ring, astronomers have uncovered something unexpected: faint chemical signatures of complex molecules drifting through the void. These aren't just any compounds, they're polycyclic aromatic hydrocarbons, or par-carbon-rich structures that resemble microscopic soot flakes. Normally found in the dusty corners of star-forming regions, their presence here wouldn't be unusual if they weren't behaving so strangely. Instead of spreading evenly across the ring, these PAHs cluster in peculiar, asymmetrical patches. Some zones gleam with their infrared fingerprints, while neighboring areas appear startlingly clean. It's like finding campfire smoke concentrated in random puffs across a forest, defying the wind's natural spread. What's even more puzzling is their role in the ring's ecosystem. PAHs usually act as cosmic building blocks, absorbing starlight and re-radiating heat, which helps regulate star formation. But here, their patchy distribution suggests they're participating in a far more nuanced dance. One theory points to radiation shaping their strange arrangement. The ring's young, massive stars flood their surroundings with ultraviolet light, which can break apart PAHs or push them into denser pockets like leaves swept by a hose. Yet the pattern doesn't fully match the star's location. Some brightly lit zones lack PAHs entirely, while shadowy regions inexplicably harbor rich deposits. This disconnect hints at hidden forces at play, perhaps magnetic fields corralling the molecules into sheltered alcoves. The real intrigue lies in their origins. These complex hydrocarbons typically form in the winds of aging stars or supernova debris, yet Hoag's Object's ring is dominated by stellar youth. Could they be remnants of earlier, now vanished generations of stars, or did they hitchhike into the galaxy aboard interstellar dust clouds, seeding the ring with pre-made organic material? Their mere existence suggests chemical processes we've yet to map, a hidden layer of cosmic chemistry unfolding silently amid the starlight. Every irregular patch of these molecules is more than a curiosity, it's a clue. In a universe where carbon is the backbone of life, their odd distribution begs the question: are we witnessing the faint echoes of cosmic recipes that could, under the right conditions, spark something even more extraordinary? For now, these PAHs remain enigmatic, weaving an invisible tapestry of complexity through the galaxy's iconic ring. While the golden core of Hoag's Object appears tranquil in visible light, X-ray telescopes reveal a ghostly embrace, a faint, diffuse halo of high-energy radiation surrounding the galaxy's heart. This ethereal glow spans thousands of light-years, pulsing with whispers of violent pasts or hidden activity. But what's casting this X-ray shroud? Astronomers are locked in a cosmic detective story, chasing two very different suspects. The first clue points to scorching intergalactic gas. If the halo stems from million-degree plasma, it could be the aftermath of ancient starburst supernova explosions heating the core's surroundings like a celestial furnace. Gas this hot would emit X-rays naturally as it swirls in the galaxy's gravitational grip. Yet there's a hitch: the radiation's distribution doesn't quite match typical starburst patterns. Instead of a smooth cloud, the glow shows subtle filamentary structures, as if something's stirring the pot. That anomaly fuels the second theory, a graveyard of dead stars. Neutron stars and white dwarfs, relics of stellar explosions, can emit X-rays as they slowly cool or accrete stray material. In this scenario, the halo wouldn't be a true gas cloud at all, but the combined faint glow of countless unresolved stellar corpses. Supporting this idea, the X-ray spectrum lacks certain telltale emission lines expected from pure hot gas, hinting that stellar remnants might dominate the signal. But the plot thickens. Some researchers argue for a hybrid solution, both gas and stellar remnants contributing to the haze. Turbulence from the core stars could keep the gas agitated, while past supernovas seeded it with invisible dead stars. If true, this X-ray halo becomes a layered archive, preserving clues about the core's most cataclysmic epochs. Until sharper telescopes dissect its light further, one thing's certain: even in stillness, Hoag's Object's heart crackles with unresolved energy, a reminder that galaxies wear their histories in more than just starlight. Stretching like ghostly threads beyond Hoag's Object's luminous ring, astronomers have spotted faint, ribbon-like extensions, potential tidal tails, the cosmic footprints of a long-ago collision. These tenuous trails of stars and gas don't just drift aimlessly, they curve with purpose, as if tracing the trajectory of a catastrophic encounter billions of years in the past. If confirmed, these filaments would be smoking gun evidence that the galaxy's iconic ring wasn't born in isolation but forged in violence. Reconstructing the crash that might have created these tails is like piecing together a celestial crime scene. The curvature of the extensions suggests the intruder didn't hit head-on but sideswiped Hoag's object at an angle, its gravity-peeling material outward like taffy. Simulations show the encounter would have been spectacular: a smaller galaxy, perhaps 1/10 the size, grazing the edge of Hoag's object and scattering stars into these faint arcs. The odd part, the tails aren't symmetrical. One side stretches farther and appears more diffuse, hinting the collision was messier than we thought, with turbulence or magnetic fields altering their evolution. Yet the lack of visible debris raises questions. Most tidal tails from similar collisions are littered with star clusters or distorted gas clouds, but these extensions are eerily clean. Some researchers argue the culprit might have been a gas-rich dwarf galaxy, its stars too sparse to leave obvious wreckage. Others propose the tails are older than they appear, their stars gradually fading into the void over eons, leaving behind only these barely detectable traces. The most intriguing clue lies in their motion. By measuring the subtle Doppler shifts of the tail stars, astronomers have noticed something unexpected. They're not all moving uniformly. Some clumps race ahead while others lag, as if the original collision sent material flying at different speeds. This chaotic velocity mix could mean the encounter wasn't a single clean strike but a series of gravitational tugs, like a stone skipping across a pond. Whether these filaments are true tidal tails or something stranger, their presence rewrites Hoag's Object's origin story. This galaxy, so often hailed as the epitome of cosmic order, might owe its perfection to an ancient moment of chaos, a fleeting clash that stretched its stars into whispers, now barely clinging to the edges of visibility. And as telescopes probe deeper, these faint extensions could reveal not just how the ring formed, but how galaxies heal after unthinkable violence. Buried deep within Hoag's Object's tranquil core lies a gravitational enigma that refuses to stay hidden, an invisible force so powerful it bends the very fabric of space around it. For years, astronomers assumed this galaxy lacked a supermassive black hole, given its serene appearance and missing telltale signs of violent accretion. But new observations suggest something massive is lurking in the shadows, defying expectations once again. The evidence starts with motion. Stars near the core whip around at dizzying speeds, their trajectories hinting at an unseen gravitational anchor weighing in at millions of solar masses. Normally, that kind of pull points squarely to a supermassive black hole, yet other clues contradict the story. There's no brilliant quasar-like glow, no swirling disk of doomed matter, just an eerie silence where astrophysicists expect cosmic fireworks. Some researchers argue the data could be misleading. Perhaps an unusually dense cluster of neutron stars and stellar remnants packed tighter than anywhere else in the galaxy creates the illusion of a single massive object. Others point to dark matter's invisible hand, suggesting its uneven distribution might mimic a black hole's gravitational grip without the need for one. But here's where things get even stranger. Recent radio wave detections reveal faint, flickering emissions from the core's heart, signatures often linked to black holes feeding on stray gas. These sporadic bursts are too chaotic to stem from stars alone, yet too weak to match typical active galactic nuclei. Could this be a dormant giant stirring just enough to betray its presence? Or is Hoag's Object playing an elaborate cosmic trick, crafting illusions from forces we don't yet understand? The debate cuts to the core of galactic evolution itself. If a black hole does hide here, it challenges our models of how these behemoths grow in seemingly isolated galaxies. And if one doesn't, then Hoag's Object rewrites the rules entirely, proving galaxies can anchor themselves without the universe's most infamous predators. Every quiet flicker from its core forces us to question, are we seeing the exception or just how little we truly know? hidden within the sparkling expanse of Hoag's Object's ring, a cosmic balancing act is unraveling. Pairs of stars bound by gravity are being torn apart. These binary systems, usually locked in stable orbits for billions of years, are showing signs of distress in the galaxy's unique environment, the culprit. A gravitational tug-of-war between the ring's dense structure and the unseen pull of dark matter. Binary stars rely on predictable forces to stay paired, but Hoag's Object's perfectly aligned ring creates a precarious playground. As these stellar duos orbit, they're subjected to subtle yet relentless tugs from the galaxy's unusually smooth gravitational field, stretching their bonds like overstrained rubber bands. Some pairs wobble erratically, their orbits warping under the strain. Others have already surrendered, one star flung outward while its companion drifts inward, forever separated by forces they couldn't resist. There's an even stranger twist. The disrupted binaries aren't scattered randomly. They cluster along the ring's inner edge where gravitational shear is strongest. This pattern suggests the galaxy's rotation itself is acting like a cosmic shredder, peeling stars apart at precise points where motion and mass conspire against them. Yet some binaries defy the chaos. A handful of tightly bound pairs endure, their orbits so close they resist the external forces. These survivors could be the key to understanding the threshold of stability, what makes some stars cling together while others are ripped apart. Each disrupted pair leaves behind a trail of clues, written in their velocities and paths, hinting at the invisible forces reshaping the ring from within. This gravitational ballet isn't just about broken partnerships, it's a live experiment in how galaxies sculpt their stars. And in Hoag's Object's case, the results are clear. Even the universe's most perfect ring has a way of testing the limits of celestial loyalty. Deep within Hoag's Object's golden core, ancient stars wage a silent war that echoes across the galaxy. Every dying giant and newborn blue star unleashes torrents of stellar wind, rivers of charged particles racing outward at millions of miles per hour. Supernova erupt like clockwork, blasting shockwaves through the surrounding void. Together, these forces form a feedback loop that should be shaping the entire galaxy, sculpting gas clouds and triggering new star formation in the ring. Yet something's off. The impact is far weaker than astrophysicists predicted. The math is straightforward. With so many massive stars packed into the core, their combined energy should be punching holes in the ring's structure, carving bubbles and triggering waves of star formation. Instead, the ring remains eerily undisturbed, its symmetry flawless. One explanation points to an unexpected buffer. Dense layers of gas might be absorbing that energy like a cosmic sponge, dissipating shockwaves before they reach the outer band. Imagine shouting into a blizzard. Your voice gets muffled by the snow. Similarly, Hoag's Object's core could be wrapped in a shroud of material that silences its fury. Another clue lies in timing. Core stars might be burning out in staggered generations, their bursts of feedback spaced just far enough apart to avoid overwhelming the system. Supernova that should have been catastrophic could instead be firing in gentle waves, like a drummer tapping a rhythm rather than slamming the kit. Supporting this idea, the ring's star-forming regions appear in clusters rather than uniform spreads, consistent with sporadic rather than constant triggering. But the most intriguing possibility, the feedback might be there, just redirected. Magnetic fields threading through the galaxy could act like invisible gutters, channeling stellar winds and radiation along specific paths away from the ring. Instead of dispersing chaotically, energy might flow along these hidden conduits, venting harmlessly into intergalactic space. It's a cosmic stealth system, hiding the core's violence in plain sight. Whether it's buffering, timing, or unseen magnetic highways, one thing's clear: Hoag's Object has found a way to whisper where other galaxies scream. And in that quiet, we're left to wonder, how many other cosmic marvels hide their tumult behind veils of perfect order? The final mystery of Hoag's Object might be its most energetic, an invisible bombardment of cosmic rays streaming from its perfect ring at intensities that defy explanation. These aren't just random high-energy particles, they're a torrential downpour crashing into the galaxy's structure with enough force to illuminate entire star clusters. Normally, cosmic rays trickle through space as background static, but here they surge like a cosmic storm, and no one knows what's fueling the deluge. One leading theory points to stellar cataclysms. The ring's blue star clusters are factories for massive, short-lived stars that die young and violently. Each supernova detonation could be launching particles to near-light speeds, creating shock waves that act like natural particle accelerators. The math almost works, except the observed cosmic ray excess is clustered in patches, not spread evenly across the star-forming zones. It's as if something is focusing these particles, channeling them into specific corridors of the ring like cosmic lightning rods. That anomaly has researchers considering a far more exotic possibility: dark matter's fingerprints. If certain theoretical particles decay or collide in Hoag's object's halo, they might produce cosmic rays as a byproduct. The ring's structure could then act as a trap, concentrating these particles along its edges. Supporting this idea, the excess aligns suspiciously with gravitational models of where dark matter's influence would be strongest, not quite matching the visible starlight, but hovering just beyond it like a shadow. Yet the most puzzling detail is the ray's energy signature. Some particles blast through with energies so extreme they rival the most powerful quasars, suggesting an engine far more potent than ordinary supernova. Could there be an unseen population of hyperactive neutron stars or rogue black holes lurking in the ring, their magnetic fields launching particles into overdrive? Or is Hoag's object tapping into something even more fundamental, a universal particle accelerator we've yet to comprehend? For now, every detector trained on the galaxy captures the same enigma, a ring that shouldn't just glow with starlight but crackle with invisible fury. Whether it's dying stars, dark matter, or some undiscovered force, one thing's certain: this cosmic ray excess isn't just noise. It's a shout from the void, proof that even the universe's most serene structures harbor unimaginable violence. After journeying through 50 cosmic oddities within Hoag's object, from its counter-rotating core to ghostly tidal tails and rogue carbon stars, one truth becomes undeniable: this galaxy isn't just an outlier. It's a cosmic rebel rewriting the rules at every turn. Each anomaly we've uncovered isn't just a curiosity, it's a crack in our understanding of how galaxies evolve. The missing planetary nebulae, the lopsided ring mass, the whispering dark matter halo, they all point to processes we've barely begun to decode. What makes Hoag's object so thrilling isn't just its strangeness, but how it holds up a mirror to our own assumptions. For decades, astronomers treated it as a beautiful oddity, but now we see it for what it really is: a challenge. A single galaxy daring us to question everything from gravitational models to stellar life cycles. Could its perfect ring be a fleeting moment in cosmic time? Are we witnessing a rare phase of galactic equilibrium, or evidence of forces we've yet to name? The real magic lies in what we don't know. Those 50 mysteries aren't dead ends, they're invitations. Every time a telescope uncovers a new wrinkle, it's a reminder that the universe is stranger than any textbook could capture. And that's where you come in. The next breakthrough might start with a curious mind staring at the stars. So tell us, which of Hoag's object's enigmas left you spellbound? Was it the phantom black hole, the vibrating ring, or the gamma-ray whispers? Drop your favorite in the comments, and if you're hungry for more cosmic deep dives, hit subscribe. The universe isn't done surprising us, and neither are we. Until next time, keep looking up.